Hello, 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 hello. Hello everyone, welcome to Unacademy. In today's class, we are going to discuss about the concept of limits. Probably within 2 to 3 days, we will be able to bind up an important topic within the mathematics, and that is been limit. And you can say out of two number of papers, definitely one paper carries one question from the concept of limit. Usually the question do come from this particular reason in a form of numerical, like they may ask limit x tends to 0 of sine of x divided by of x. They may ask limit x tends to 0 of cos square x divided by of x. This kind of the questions are been repeatedly asked, and usually the label of the questions would be almost same as we had discussed about this concept, or which we had studied about this concept in class 12th as well. So everyone, put the heading which we have been discussing in today's class is going to be the concept of limits. We are going to focus over the concept of limits. Anyways, before starting this concept, let me focus over the indeterminate case. So let me focus over the indeterminate case. Indeterminate cases, because most of the questions which is being asked from this particular topic now usually falls from the category of the indeterminate case. So there are total 7 different indeterminate case that we are going to write now. So you had to have a little bit idea about those all intermediate cases. The first is being 0 by 0. Why the 0 by 0 is been indeterminate case? That is not been the area of concern, at least in my today's class. Because if I'll go behind the reasoning behind the each and individual 7 different indeterminate cases, it will take huge amount of time, and my complete course is just been planned for the GATE 2023. So I would say only one thing: if you really know how, from where this concept of indeterminate case had come and why 0 by 0 has been an indeterminate case, is well and good. And if it's not aware of those facts, definitely keep aside for the time being, because you have been preparing for GATE 2023. So 0 by 0 is been a case of indeterminate. Same goes with infinity over by infinity. Again, it has been an indeterminate case. Then goes infinity minus infinity, it's an indeterminate case. Now the next what you can do, the infinity must have been brought towards numerator side, or 1 upon infinity must have been dealt separately. So 1 upon infinity stands for 0. So 0 into infinity is again been a indeterminate case. It's again been a indeterminate case. In the same sequence, I can write infinity to the power of 0, then goes 1 to the power of infinity, and 0 to the power of 0. These are 7 different 1, 2, 3, 4, 5, 6, 7 different indeterminate cases, and this must be clear to all of us. Nobody should write 0 by 0 as 1 or 0, infinity by infinity as 1 or infinity or 0. Nobody should write infinity minus of infinity as 0 or infinity. No. The reason I'm not interested to talk about their reasons, at least in today's class. Agreed? No? So this concept must be clear to all of us. Apart from 7 indeterminate cases, the remaining cases are been determinate case. What does that actually mean of determinate case? That means their result would be predefined and it would be actually known. You can't say 0 by 0 stands for 1, maybe 2, maybe infinity, maybe 0. That is why it is been called of indeterminate case. So let me do one thing. Let me take an example. The things would be clear to all of you. See, 0 by 0, let's take 0 by 0 is being the ratio of 12 minus 12 divided by of 6 minus 6. Obviously, numerator is being 0, 12 is getting subtracted with the 12, will result 0. Denominator is being 6 minus of 6, again subtraction is being taken with the same number, it's again being 0. So one person may take 2 common out of the numerator, and the factor which had been left out is just been 6 minus 6, and here it goes 6 minus 6. And if he cancels 6 minus 6 over 6 minus 6, the result is being 2. You can take another scenario as well. 0 by 0 is also being taken as Let's take 10 minus of 10, that is stands for 0, over 10 minus of 10 again, which is stands for 0. Again, if you have been cancelling out, the result is supposed to be 1. So virtually speaking, if you think 0 by 0 is stand for 1, so I had given a counter question for that. This is stand for 2. So that is what I am saying. You need not to have any second thought. The 7 number of cases which are been written over the digital board, they all are been the indeterminate case. They all are been indeterminate case. What does it actually mean of it? You can take few number of examples, and with the help of those examples, probably I would be able to teach you in the better way. Let's take you had a problem. The limit x had been tending towards 0, which had been applied over a function. Numerator is been sine of x and the denominator is been x. What the people are going to do? They are going to feed x as 0 in numerator as well as denominator. And as we know, the sign of 0 is being 0 and x is being fed as 0. So denominator is also being 0. Many of the student may write 0 by 0 as a 1 or a 0. But the thing which had already been taught in today's class, this has been falling in the indeterminate case or the case of 0 by 0. So either you can't write this as 1 or 0 until and unless you are simplifying this problem even further. If you want, we can take another problem as well. Let me take another problem where the independent variable is been n, which had been tending towards infinity. The function on which the limit is being applied is been n divided by of n square plus of 1. Again, n has been fed to infinity towards numerator as well as denominator. Once you'll feed n is equals to infinity, at numerator it would become infinity, and towards denominator it would become infinity square plus of 1. Obviously, infinity has been a very large value, so its square is also going to be an ultra large value. It is been added with 1, remains a very large value. Square root again remains a very large value. So the result is been infinity over infinity. You can't write this as 1, 0 or infinity, because again infinity by infinity has been an indeterminate case. So what has been the conclusion behind few number of questions which I had taken in today's class? Whenever you find any kind of category which had been listed over this problem, definitely you had to resolve the case of indeterminate. You have to come down to the determinate case, then only you can do something. If you want, I can take another example as well. What I had been doing, let's take another function which had a independent variable x. This has been like 1, and I can say 1 divided by of x square plus of 1. And let's take the x is been tending towards infinity. And as the x has been tending towards infinity, you yourself would be able to see the denominator becomes infinity, a very large value. 1 upon infinity would become 1 to the power of 0. 1 to the power of 0. And you yourself would be able to understand, yes, this has been a case of determinant. So by just plugging the data as x is equals to infinity, you could have get this answer. But the complete scenario must have been different if the situation must have been falling in this region, or I should say, rather writing 1 upon x square plus of 1, if this must have been a 1 to the power of x plus of x square. And if I feed x tends to infinity, or if I feed x is equals to infinity, 1 remains as it is. This has been your base, but the exponent becomes infinity, and 1 to the power of infinity is again been an indeterminate case. So whenever you had an indeterminate case, you had to bring back that indeterminate case into the form of determinate case, and then only you will be able to smash the problem. This has been an indeterminate case, and many of the times I had seen many of the students used to have doubt, sir, okay, we had a 7 number of indeterminate case, but still I had doubt with few number of more cases whether they have been determinate or indeterminate. Apart from these 7 cases, all have been determinate cases. Like if you write 0 into 0, obviously it has been a determinate case. Let me write it down. 0 into 0, it has been an indeterminate case. A very small value has been multiplied with a very small value will lead a very small value, and it remains a determinate case, because 0 into 0 always stands for 0. Many of the students may also have the doubt with the infinity. After getting multiplication and addition, what would be their nature? See, a very large value is being added with a very large value will result a very large value. Obviously, infinity plus infinity stand for infinity. Same goes with their multiplication as well. So these all are in the determinate case. So nobody should have any kind of doubt, at least over the determinant as well as non-determinate cases. If you have been dealing with the problems which falls in this reason, definitely you must have straight away written the answer is 0, infinity or infinity. But this is not been the case because the cases are been indeterminate. So there you had to resolve the problem. You had to bring that problem into the determinate form. Then only you will be able to do anything. You will be able to do anything. Is that part clear to all of us? Is that part clear to all of us? So this concept must be clear to all of us. So in the same sequence, I think it's been the right time. I should be talking a bit about the concept of limit. What does it actually mean of limit? The name itself has been self-explanatory. Limit. Let's take, we had a function which carries one number of independent variable. For the time being, that independent variable is being taken as x. Let's take u wants to scrutinize the worth of the function, value of the function at x is equals to c. Exactly not x is equals to c, at x is equals to c. So what you have been doing? You have been trying to reach at x is equals to c from left hand side. You didn't reach exactly at x is equals to c. You have stopped yourself just before x is equals to c. So virtually speaking, you had stopped yourself at c minus just before c. And similarly, if you have been again trying to reach at x is equals to 3 from right hand side, and if you have stopped yourself just before x is equals to c, that means you had been standing in front of c from the right hand side, in front of c from the left hand side. I must say this as a c minus and this as a c plus. If the worth of the function has been quite same at c minus and c plus, I say the limit do exist at x is equal to c or around x is equal to c. Keep in mind, limit is nothing to do with the worth of the function precisely at test point. I need not to worry about the worth of the function at x is equals to c, whether it has been defined, whether it has been undefined, whether its worth has been same as fc minus, fc plus, or whether it's been completely different than fc minus of fc plus. I do not worry about at all. Did you understand what I'm saying? So as far as the limit is being concerned, I do not exactly come down to the point of interest. I tried to reach to that point. Let's say this has been my xy plane. Here comes x-axis and here it's been y-axis. My point of interest has been x is equals to c, which is supposed to be a vertical line at x is equals to c. So this has been a vertical line, x is equals to c. X is equals to c. Agreed? Randomly I had taken a function. Let's take the function has been drawn something like this. Something like this. Yes, something like this. As far as the limit at x is equals to c is being concerned, what I would do, I would try to reach to x is equals to c from left hand side, and I would stop myself just before x is equals to c, and same thing I do from right hand side as well. So as I had stopped myself just before c, that means I had been standing at c minus and similarly c plus. The worth of the function just before c could have been taken as f of c minus, and the worth of the function just after c could have been taken as fc plus. And keep in mind, this fc minus and fc plus is also being called of left hand limit, and this has been called of right hand limit. Listen, this has been called as left hand limit, and this has been called as right hand limit. And if the left hand limit is being very same as right hand limit, I say at my test point, which is been x is equals to c, at least at this observation, is found to be constant. Agreed? So limit do exist in this case. Mathematically, how it is being written? My test point is being c. So the left hand limit is also being written as limit h tends to 0, limit h tends to 0, f of c minus h. That means a very least or smallest value is being subtracted from c. So you had been standing yourself at f of c minus is being same as limit h tends to 0 of f of c plus h. Till this point, I feel each and individual concept must be clear to all of us. In first slide, I was talking about the different indeterminate and determinate cases. There have been absolutely 7 number of indeterminate cases. The name itself has been self-explanatory. The cases where the exact result is not been known. Many of the times we used to be in ambiguity. We used to be in dilemma. What to do with the 0 by 0? What to do with the infinity by infinity? What to do with the infinity minus infinity? What to do with 1 to the power of infinity? So I would request to each one of you, better to have a little bit idea about this 7 number of cases, or in short I can say you can mug up this 7 number of outcomes. Nobody should write in future 1 to the power of infinity as 1 or maybe 0 or maybe infinity. No, you can't do so. Anyways, each and individual indeterminate cases had its own logic from where they had been called for indeterminate cases. But this will not be my area of concern, at least at this moment of point, because we have been preparing for GATE 2023 and GATE 2023 is approximately 1 month ahead. So this has not been the right time to discuss in a great detail. So my focus would be communicating the important concept. Once the important concept is been known, better to do the quite good number of practices. That has been my area of concern. And at the same time, once we stack down the 7 number of indeterminate cases, many other times you also will have a doubt, sir, what with 0 into 0, infinity into infinity, infinity plus infinity. So you can mug up this outcome as well for the time being. So that is why I had taken few number of examples where most of the students used to get stuck, and even in my time also I had the problem with this kind of functions where the resultant were 0 by 0, maybe infinity by infinity. I was getting stuck. If you want, I can take another example as well. This question has been asked in GATE Civil Engineering probably 4 years ago. Limit n tends to infinity of n minus of n square plus of 1. Many of the students, what they would do, they would straight away feeding the value of n as infinity. Once they had fed n is equals to infinity, the first term becomes infinity, even the second term also becomes infinity, and they come to a position where the infinity is getting subtracted with the infinity. Many of them would write infinity minus of infinity as infinity, and many of them may write this as 0. And keep in mind, the infinity minus infinity is been an indeterminate case. So yes, you have to bring this case to the determinate form. And usually for bringing indeterminate cases into the determinate form, I use the concept of L'Hopital rule, L'Hospital rule. Here comes the graphical as well as the mathematical understanding of the limits. What does it actually mean of limit? The limit states a limit do exist at a test point x is equals to c if the worth of the function just before c, or I should say c minus, and just after c, I should say c plus, has been quite same, or I should say there had not been any sudden jerk at this moment of point. Like you must have seen the share markets. If the pricing of any of these stock is being keep moving, okay, but what happens once the market gets closed at 3:30 and again it gets open in next day 9 o'clock, you will see there would be a abrupt change in their pricing. Obviously I would say the limit do not exist at that point because there had been the abrupt change in this pricing. Like in Siam metal, I had taken reference of share. The Siam metal had gone down by 6% in today's share market, taking the reference of LTP, last traded price. So I can say this point has been a point where the limit do not exist because there had been a abrupt change. Yes, but anyways, the limit do exist if the left hand limit is been very same as a right hand limit. Now let me go ahead taking few more important concepts. My dear friend, if I would say find the limit x tends to 0 on x square plus of 2 of x, may I know what would be your methodology? How will you address this kind of problem? The first methodology must have been you go ahead with the traditional mathematical approach for finding limit. You find its left hand limit, then go ahead with its right hand limit, compare them. If it is been same, you will have the value of limit, and that is been equals to of left hand limit or right hand limit. But this process takes unnecessarily good amount of time. So you need not to follow this manual method. We could have understood, or we could have solved this problem using a unconventional method. May you know what has been that? My dear friend, it is already been communicated probably day before yesterday. Any kind of polynomial is going to be continuous in an entire region of x. And it is already been seen, if the function is being continuous at any moment of point or at any test point, by default the limit do exist at that point. If the function is being continuous in an entire region of x, by default it would also have a limit existence in entire region of x. So what to do? Rather calculating f of c minus or f of c plus, why don't we calculate f of c straight away? So rather calculating LHL, RHL, straight away I could have fed x as 0. That must have been given the value as f of 0, and keep in mind, as I know earlier, the function is been continuous in entire region of x, including x is equals to 0. So rather calculating f of 0 minus, that has been left hand limit, or f of 0 plus, that has been right hand limit, I must have been calculated the f of 0 itself. That is what it's been all about. So what has been the outcome, or what has been the learning from this question? As this has been a polynomial, this has been a polynomial, and polynomials are always been differentiable in entire region of x. And as it has been differentiable, by default it is going to be continuous, and limit will also exist. Anyways, let me go ahead with its solution. The solution starts from here. If we know the function is being continuous in an entire region of x, or I should say left hand limit is been same as the right hand limit, and it's been same as the worth at x is equals to 3. Quite okay. Calculation of left hand limit and right hand limit requires a bit mathematical calculation. So rather focusing over the left hand limit and right hand limit, I must have been focused over the f of c itself. Either it's been x is equals to 0, 1, 2 or 3. So my approach states, rather calculating this or this, you must have calculated this, and that is nothing but the worth of the function at test point, and the test point is being 0. So straight away this must have been 0 square into a plus 2 into 0, and the worth must have been 0. If somebody would say what had been the worth of limit x tends to 0 of x square plus of 2x, so rather calculating left hand limit or the right hand limit, you had straight away calculated the worth of the function at x is equals to 0, and obviously such a minimal amount of effort you had been put in for calculating the answer, and the answer is simply going to be 0. Let me take another question. If I had been changing the structure of this problem a bit, rather taking x square plus of 2 of x, if I had taken x cube plus 3x square plus 2 of x, a bit change has been placed over here. So rather taking x square plus of 2x, what I did, just have a look of it. I had taken a polynomial which is 3 in degree. So may I know what would be the worth over here? The same thing has to be done. Again, it has been a polynomial. So if it has been a perfect polynomial in an entire region of x, the given function is going to be differentiable, virtually speaking continuous, as well as the existence of the limit is being also ensured. So what you do, rather calculating the left hand limit or the right hand limit, you must have been calculated the worth of the function at x is equals to c, where the c is been a test point, and here the test point has been simply 0. So may I know what must have been the answer over here? The answer must have been simply 2. I know many of the students might had calculated limits many of the times, but most of the students exactly do not know whether they have been doing correct or not. You had been doing correct because consciously or unconsciously you had taken that given function is being continuous at my test point. So rather calculating left hand limit or right hand limit, why don't we calculate the worth of the function at x is equals to c itself? So that is what I am saying. No, that's been the difference. Rather writing limit x tends to 0, you could have written f of 0. Is it been same? What I am saying, is it been same? Limit x tends to 0 of the given function f of x and the worth of the function exactly at x is equals to? No, this is not been same. This won't be same if the limit is not been continuous at x is equals to 0. But yes, this would be quite same if the function is being continuous at x is equals to 0. So far, wherever the question had been framed, what you have been doing, rather calculating its limit, you were calculating its worth of the function at x is equals to 0. But still, all of the answers were correct because fortunately, the point at which the calculation were made is being found continuous. If it has been discontinuous, this answer will not be prevalent. This answer will not be prevalent. Is that part clear to all of us? Just a minute. Agreed? Till this point, I don't find any of the student would have any kind of doubt. If you guys are having any kind of doubt, you can put it over the live chat. Definitely, I will try to respond to your doubts as well. So let me take a few more variant of the questions, and over the period of time, I would raise the level of the question, and we will go beyond even the questions which have been raised in GATE examination. So let me take another question. Here comes the next question is being limit x tends to 0 of mod of x. This kind of questions are been rarely asked in GATE examination, where we had been finding the existence of the limit for a modular function. Keep in mind, the modular function is being a continuous function. That is separate story together that at x is equals to 0, the function is being non-differentiable. At least in this moment of point, I have nothing to do with the differentiability. I have just to do with continuity. If the function is being continuous in an entire region of x, by default, the limit would exist in an entire region of x. And the left hand limit would be very same as the right hand limit. And fortunately, it would be very same as the worth of the function at a text point x is equals to c. Although mod of x would make a V-shaped curve, but still at x is equals to 0, the function is being continuous. There had not been any sudden jerk, or there had not been any sudden change at x is equals to 0. So be happy with that. So rather calculating the left hand limit or right hand limit, straight away calculate the worth of the function at x is equals to 0 itself. So what I am saying, so let me start the solution over here. So here starts the solution. So if you have been willing to calculate its limit, you must have calculated the left hand limit, that is been the worth of the function at 0 minus, and similarly you must have calculated its right hand limit. If both of the values are been same, that value must have been the worth of the given function, or limit x tends to 0 of that given function. Agreed, sir? At least I know at x is equals to 0, magnitude of x or mod of x is been a continuous function. If you want, I can write it somewhere here. As we clearly know, the magnitude of x is being a continuous function, at x is equals to 0. And as it is being a continuous function at x is equals to 0, what does it actually mean of it? The limit do exist, and the worth of the limit, left hand limit and right hand limit, would be quite same as the worth of the function at x is equals to 0. So rather calculating LHL or RHL, straight away let me calculate the worth of the function at x is equals to 0 itself. So I can say this I could have written as limit x tends to 0 of f of x, where the f of x is been magnitude of x. So what I have been doing over here, I had been calculating the worth of the function at x is equals to 0, virtually speaking magnitude of 0, and the magnitude of 0 is been 0. Yes, so I don't find any of the student would have any kind of doubt, at least at this moment of point. Agreed, no? So let me do one thing. Let me take few more number of questions. And deliberately, I had been bringing the concept of indeterminate cases in upcoming questions. That means your questions would fall from either of the category. Either in the case of 0 by 0, infinity by infinity, infinity minus infinity, 0 into infinity, infinity to the power of 0, 1 to the power of infinity, or 0 to the power of 0. So let me take few number of questions, because from this frame of questions, The questions have been repeatedly asked. Let me do one thing. Let me take a question. Limit x tends to pi by 2 cos of x divided by of x. May I know what would be its worth? What would be its worth? One thing has been quite sure. Cos of x is going to be a continuous function in the entire region of x. And x is being a polynomial with a first degree, it is going to be a continuous in the entire region of x. So what we have been doing here, the x is equals to pi by 2 is been plugged with the cos of x as well as x. Why? Because left hand limit and right hand limit is going to be same as the worth of the function at x is equals to pi by 2 separately for cos of x as well as x. So rather calculating left hand limit or right hand limit, why don't we feed the value straight away? Because the function at least at entire region of x has been found as continuous. So what I did over here, so I had just fed x as pi by 2, and at towards denominator also we had fed the value as pi by 2. Numerator had become 0 and the denominator has been pi by 2. Many of the students might apply the L hospital rule in this question. No, not at all required, and you can't apply as well, because there had only been the 7 different variants of indeterminate, which includes 0 by 0 and infinity by infinity, but this has been case of a 0 to a non-zero constant value. So obviously the result is supposed to be 0. Nobody should apply the L hospital rule. So this has been a caution over here. This has been a caution over here. Nobody should apply the L hospital rule. No. It has been a dangerous point. Caution, I can say. Caution is to be applied. Yes. Agreed, no? Till this point, I don't find any of the student would have any kind of doubt at least. Let me take another question now. So here comes the next question. Let me write another question. And this question is stand for. Again, the limit is to be calculated, where the x is being tending towards 0. And here the function is being sine of x over x. This has been the next question. This has been the next question. Here comes the next question. Yes. Tell me what would have been the bestmost answer for this given question. What must have been the bestmost answer for this given question? What must have been the bestmost answer for this given question? What must have been the bestmost answer for this given question? Again, the sine of x is going to be a smooth curve in an entire region of x-axis. And same goes with the x as well. X is going to be a linear polynomial, and the polynomial would remain differentiable in an entire region of x. And as it has been differentiable, by default, it is going to have been continuous, as well as the limit do also exist. So what I am going to do, rather calculating the left hand limit and right hand limit, straight away I had been plugging x is equals to 0 in numerator as well as denominator. So yes, this pattern I have been following at least from here. So when I would feed x as 0 in numerator, so here comes sine of 0, and towards denominator also it's been 0. Sine of 0 is stands for 0, and denominator is already been 0. It is already been seen in first most slide. 0 by 0 is been a case of indeterminate. You can't write 0 by 0 as 0 or 1. No, you should not do so. If you want the explanation behind it, already the explanation has been given in the first slide. But as it had been communicated earlier, my basic methodology of teaching at least this mathematics over the Gate Academy Global is just to teach the complete concept through the question only. Because if I'll go behind the detailed explanation of the each and individual concepts, probably it may take more than 150 hours, and definitely this much time you can't spare with me. Not at all required. So what we have been doing, whenever you had come up with this situation, I think it's been the right time I should use the L hospital rule. L hospital rule. So what I would do, I would take the differentiation at numerator as well as denominator, and once we had done it, so the numerator had become cos of x and the denominator had become x is been again divided with 1 x, so it's been 1. The same limit has to be kept in. The limit has to be fed in same. So x has been fed as 0, so cos of 0 has been 1 over 1. The result is been simply 1. The result is been simply 1. So as far as the problem of sine of x over x, where the x is been tend to 0 is being concerned, the answer is supposed to be 1. Let me take another question. And let's take it has been limit x tends to pi by 2 of sine of x over x. Deliberately I had changed the nature of the question a bit because this sort of questions are rarely asked and people used to by heart the each and individual questions, and that is why the next question had come in front of you. Again, sine of x is been a continuous function in an entire region of x. Same goes with x as well, because sine of x has been an oscillating signal and nowhere it is been framing a curve. Obviously, sir, it had been a continuous in entire region of x, and x is been a polynomial with a degree of 1. It had already been communicated. If you have been dealing with a polynomial, the polynomial is going to be a smooth and continuous curve in entire region of x. So what we have been doing, rather calculating its left hand limit or right hand limit, left hand limit and right hand limit, I could have calculated the worth of the function at the test point itself, and the test point has been pi by 2. So what I would be doing over here, at least in this problem, straight away the numerator sine of x would be fed as a pi by 2, and same goes with the denominator as well. So yes, so here it becomes sine x is been fed as pi by 2, and towards denominator again it is been pi by 2, and as we know sine of pi by 2 stands for 1, and here comes divided by of pi by 2, the 2 goes upside and pi remains as it is. So the answer which we have been finding over this problem is been 2 by x. This thing must be clear to all of us. Let me take another question. What I did, I take another question. Limit x tends to pi by 2. Anyways, taking this question, let me focus over the curve sine of x over x, how it looks mathematically or graphically. You must have seen this function earlier, specifically in communication and signal system. This has been a sinc function which has been continuously oscillating with a constant frequency but a reduced or damped magnitude. So if the calculator permits, let me draw this curve, how it would exactly look. So let me draw this out. So here comes sin x divided by of x. I had been taking sin x divided by of x. So here comes, and here comes divided by of x. Just a minute. Let's see. Yes, you yourself will be able to understand. The worth has been maximum at x is equals to 0, but thereafter the magnitude has been keep damping. And as you will be going towards a larger value of x towards the right hand side or the left hand side, you yourself would be able to understand. Now the flaps are almost getting stagnant over the x-axis, or I should say the oscillation has been keep decreasing. But still my area of concern has been at x is equals to 0. You yourself would be able to see either you had been approaching to x is equals to 0 from a right hand side or the left hand side, the magnitude has been reaching to 1 only. So let me do one thing. Yes, so my area of concern has been quite same. My question is to find limit of sine x over x when the x is been tending towards 0. So the curve for sine of x over x is already been drawn. You can see this one. And you have been trying to reach to x is equals to 0. Yes, you have been trying to reach x is equals to 0. You had taken a path from left hand side and you had stopped just before 0, I should say 0 minus. And same goes from right hand side as well. And obviously I should say this as 0 plus. And if you'll force, or if you'll talk about the worth of the function at x is equals to 0 minus and 0 plus, hardly it had any difference, because the function is been smooth, or the function had not been any abrupt change at x is equals to 0. So the worth is been simply same as f of 0 minus is been plus of 1, and similarly f of 0 plus is been plus of 1. And as the left hand limit and the right hand limits are being same, obviously the limit do exist for the given function at x is equals to 0 and its worth is been 1. So what I had been telling over here, so here a limit x tends to 0 over sine x over x is been quite same, and that is been 1. that is been 1. So probably this concept must have been clear to all of us. This concept must have been clear to all of us. Agreed, no? I don't find any of the student would have any kind of doubt, at least at this moment of point. Any of the student would have any kind of doubt, at least at this moment of point. So I think this concept must have been clear to all of us. Let me go back to the working board and let me take the next question as well. What I did, rather taking sine of x over the x, I had taken sine of mx. Sine of mx. That means the sign has been expanded or shrinked. That solely depends on the value of m. If it has been positive, obviously it has been shrinked. And if it has been in between 0 to 1, it has been expanded. Anyways, it is been sine of mx over x. And again, the limit is been trying to go towards 0. May I know what would be the worth over here? The same process has to be followed. If I'll feed x is equals to 0 at numerator, it becomes 0. And same goes to the denominator as well. 0 by 0 is the case of indeterminate. L hospital rule is to be applied. I will take the first derivative at numerator as well as denominator. M would be knocked off and it would become m times of cos of x, cos of mx. And again the x would be fed as 0. Virtually speaking, it stands for m only. And towards denominator side, x is already been rubbed out. Differentiation of x stands for 1. So virtually speaking, the result is supposed to be m. If you want, I can show you over the graph. Rather taking sine of x, now I have been taking sine of 2x. And if it has been sine of 2x over x, limit x tends to 0, the result has to be 2. If it has been 3x, the result has to be 3. If it has been minus 2x, the result must have been minus of 2. So if you want, I can show you over the graph as well. So what's been the change over here? Rather taking sine x over x, I had taken sine of 2x over x. Only one change has been planned over here. So rather having x, I had taken this as a 2x. Yes, copy. Let me take another function that would be drawn in blue color. Rather taking 2x, I had taken this as a 3x. Similarly, rather taking 3x, I had taken this as a minus x. That means the value of m has been minus. And if m has been minus, sine of minus of x, it stands for minus of sine of x. So what I would do, the 2 has been removed over here and the minus sign has been brought in. The minus sign has been brought in. So tell me how the curve is going to be. You yourself would be able to understand how the curve has been. Let me focus over the red curve. The red curve stands for sine 2x over x. And this has already been calculated, or this had already been derived earlier. At x is equals to 0, the function has to be continuous. And as it is been continuous, limit should exist. And the worth of the limit x tends to 0 of sine of mx over x, where the value of m is been 2, has to be 2. And you yourself would be able to see the magnitude is been at 2. The magnitude has been at 2. And even the 3 had the magnitude as 3. And now the m is been minus 1, the magnitude is been at minus 1. So whatever the calculation has been done, that looks fantastic. But one thing has been quite sure, if you have been dealing with the functions like sine of x over x, it is going to be a continuous and differentiable function in an entire region of x. You can see very well, in the entire region of x. This must be clear to all of us. Is that part clear to all of us? Just a minute. Limit x tends to 0 of sine of mx over x is being equals to m. Now you can see very well this bluish curve is being the curve of sine 3x over x, and this red curve is being the curve of sine of 2x over x. And now which one this one, this curve stands for sine of yes. And you can see very well, if we'll come down from the left hand side and right hand side, or I should say the worth at 0 minus and 0 plus is being same as 3, is being same as 3, hence proved, same goes over here as well. Yes, f of 0 minus is being 2, is being 2. This, did you really understood what exactly I wanted to communicate? This, agreed? Is that part clear to all of us? That I would like to know from each one of you. Limit x tends to 0 of sine 2x over x is being 2. Then limit x tends to 0 of sine 3x over x is being 3, is being 3. And then comes over here, and this is being limit x tends to 0 of sine of minus x over x is equals to minus 1, is equals to minus 1. Yes, you want, you can take the value here as well. F of 0 is also been minus 1. If you want, you can value over here itself. F of 0 is also been 2, and here f of 0 has been 3. F of 0 has been 3. Agreed? And same goes with this as well. Same goes with this as well. Same goes with this as well. Just a minute. Agreed, no? Anyways, I would request to all of the students who had not gone through our subscription, they should go ahead with our subscription. What I am saying, they should go ahead with our subscription. Just a minute. Just a minute. Yes. So here comes the complete detail. Just a minute. My dear friends, if you want to onboard with us and you want to get our one-to-one mentorship, definitely you should join our paid batch, and that has been Pratigya batch for GATE 2024. So the learner who have been appearing and who are supposed to appear in GATE 2024, they can onboard with us. All of the best of the best faculties are going to mentor you for the electrical as well as electronics. The batches are already been begun from December of 15th onwards. December of 15th onwards. Same. And the amount of money which you guys have been paying, just 4,499 rupees for the subscription span of 15 months, and for 13 months you have been paying 6,499 rupees. Keep in mind, whenever you have gone for the purchase and you have been going for purchase, the code which you guys have been using or which you are going to use, it is going to be GA1111. Now the next important point has been our recorded course, where the mode of communication is going to be in English. Such a huge amount of content we have been offering you guys. For the mechanical, more than 1300. For civil engineering, more than 1300. For electrical, more than 1500. And similarly for the ECE, more than 1400. And for CSIT, more than 1100. And the amount of money which you guys have been paying, merely amount which probably we invest or we used to spend in a party itself. And that has been under 5,000, and that too subscription is been for the 15th month and 13th month, and that too you can watch the same video again and again and number of times, Agreed? And here comes our complete English course. For mechanical, the complete English course, what does it actually mean by the English and English course? In English, our terminologies are going to be in English, but our mode of teaching or the mode of concept delivering is going to be in Hindi. But in English, our complete communication is going to be in English only, including terminologies as well as the mode of communication. It is also been in a recorded form. In English, mechanical more than 700, for civil more than 900, for electrical more than 1000, ECE more than 900, and similarly for CS and IT more than 900. But the amount what you guys have been paying, such a least amount of money, you can't expect that you will be getting such a good amount of product in such a best pricing. Yes. Arjuna recorded video course, G Drive, you can just get in a amount of 2,999 rupees. It's starting from 8,999 rupees. So here basically the G Drive would be given and here pen drive would be given. So I would request at last, the AIMT All India mock test has already been running, and such a good amount of crowd has been taking part of this. So definitely you should use this opportunity and don't miss it. The dates are been 4/18, and then comes 8 January, 15 January, 22nd January, and 29th January. So anyways, hope so you could have enjoyed today's class. This is all about the today's class. We'll meet tomorrow taking few more number of numericals from the concept of limits. Till then, bye bye. Take care.